Okay, so this video is going to cover Chapter 7 of the Test 3 review packet. So first question from Chapter 7 says the diameter of ball bearings produced in a manufacturing process can be explained using a uniform distribution over the interval 2.5 to 4.5 millimeters. What is the probability that a randomly selected ball bearing has a diameter greater than 3.3 millimeters? So because we have this uniform probability distribution, this is the one where we can make the rectangle out of it. So again, I'll just draw an XY axis. And again, we want our ball bearing was between the 2.5 and 4.5. So again, this is technically starting at 0. So you can't start right there. You have to go over a little bit to where approximately you think 2.5 would be. And then we'll just go over to where we think 4.5 would be. And that is going to be the length of our rectangle. So from here to here. So from there to there is the length of that rectangle, and the length of that rectangle, the difference between 4.5 and 2.5 is 2. So the length is 2, which means when I go to find now the height of that rectangle, my height has to be 1 over 2. And I'll just complete my rectangle, and there we go. So right now the area of that entire purple rectangle is 1, but I don't want that entire area. I want the probability that the ball bearing is greater than 3.3. So 3.3 is bigger than 2.5, but less than 4.5. Let's just say it's right there. So now what I want to do, again, probability area all mean the same thing. If I can find the area of that purple shaded rectangle, then that is going to be my probability. So now to find the length, this time I'm going to do from here to here is 4.5 minus 3.3, which is going to be 1.2. And the height again is still that 1/2, or 1/2 as a decimal is 0.5. So if I multiply 1.2 times 0.5, I'm going to get 0.6, which means that there's a 60% chance that you are getting a ball bearing that has a diameter greater than 3.3. Okay. This next one is going to be the same. Suppose x is a uniform variable with c equals 10 and d equals 7. Find the probability that a randomly selected observation is less than 25. So again, we'll start with our xy axis, and this time we're going from 10 to 70. Okay, so from 10 to 70, the difference between there, or the distance between those two, would be 60, which means the height of your rectangle this time is going to be 1 over 60. So again, let's just start with our completed rectangle there. So that rectangle is the whole entire area, but again, I want to know that what the probability is that it's less than 25. So again, I'll go to approximately where I think 25 is. Let's say it's just about right there. And again, we'll complete that rectangle. It always has to have that same height. Okay, so the height is still going to be that 1 over 60. And now the length here, the difference between 25 and 10 will be 15. So, and again, if I shade that in, so the area of that blue rectangle is length times width. Again, the length is 15 and the width is 1 over 60. And if you multiply 15 times 1 over 60, you're going to get 0.25, or 25% chance. Okay. Another one like that, a machine is set up to pump cleanser into a process at a rate of 7 gallons per minute. Upon inspection, it is learned that the machine actually pumps cleanser at a rate described by the uniform distribution over the interval 6.5 to 9.5 gallons per minute. Find the probability that between 7 gallons and 8 gallons are pumped during a randomly selected minute. So again, I'll start with my graph here. And this time we're going to start at 6.5 and we're going to go up to 9.5. So the difference between 6.5 and 9.5 is 3, which means the length of this rectangle is going to be 3, which means the height is going to be 1 over that. So again, the blue rectangle is going to represent our entire area. But again, we don't want the entire area. We want between 7 and 8 gallons. So let's say maybe 7 is here and 8 is here. So now our goal is to find the area of this pink rectangle, and that will be our probability. So area equals length times width. This time the length, the difference between 8 and 1, the difference between 8 and 7 is 1. And then we'll multiply that by the height of that rectangle, which is 1/3. And when you multiply them together, you'll get 0.333 repeating. So that is your probability that it's between 7 and 8 gallons. Okay, determine whether the graph can represent a normal curve. Justify your response. Okay, number 1 on the left here, the answer is no, and the reason is because you are continuously decreasing. You can't turn back up. Okay, you can't turn back up. So that's no. The second one, again, is no. Why? Because you can't cross the x-axis. This third one over, again, it's just because of the way the picture actually looks. We're going to say that that curve is not actually touching the x-axis. So yes, this is going to be a normal curve because it approaches the x-axis, but it does not cross it, and it's symmetric. So I'll actually write that out on this one again because we're going to assume that that is not touching. So it approaches the x-axis, but doesn't cross it, and it is symmetric. Okay. This next one is no, because again, it's approaching, say, maybe this is y equals 2 up here. So it approaches y equals 2, not the x-axis, so that's a no. And the one on the right is also no because that one is not symmetric either as well. Okay, the next one, identify the value of mu and sigma and write one property about the normal curve. So you can see I pre-wrote on this slide, that's from section 7.1, and there were 5 properties. So again, you only need to write one of them. I wrote all 5. So any one of these 5 is fine. It's symmetric about the mean. The mean equals the median equals the mode. The area under the curve is 1. The area to the left of mu and the area to the right of mu are both equal, which is both going to be 1/2, and it has inflection points at mu plus 1 standard deviation and mu minus 1 standard deviation. Again, you never need to know about bullet point number 5, but again, because it was part of that section, just adding it there. And again, I'll tell you what your mean going straight down the center here, your mean is 52. And if you want to find your standard deviation, again, that's going to be the difference between those two numbers. So 58 minus 52 equals 6. So 6 is going to equal your standard deviation there. For number 7, not number 7, the next one from chapter 7, the average miles per gallon of a new model of motorcycle is known to be normally distributed with a mean of 27.4 miles per gallon and a standard deviation of 2.9. So we want to draw the normal curve with its parameters labeled. So again, we're just going to draw our curve to the best of our ability. And again, what's going right down the center is our mean. So our mean is 27.4. And again, as we go up, we are going to add 1 standard deviation. And as we go to the left, you're going to subtract 1 standard deviation. So if I add 1 standard deviation there, that's going to bring me to 30.3. If I do another one, that will be 33.2, and we'll do one more. And that one is going to be 36.1. When we go to the left, again, we're subtracting that same 2.9 this time. So the first one is going to bring us to 24.5. The next one will bring us down to 21.6. And the last one will be 18.7. So there's your normal curve with the parameters labeled. Okay, so the next question is going to ask you, we're going to come back up to that picture in just 1 second. It says, coming down here, we want to shade the region that represents the proportion of miles per gallon between 29.3 and 23.7. So we'll go back up to that picture. 23.7 is somewhere between 21.6 and 24.5, maybe right there. So we'll say that's 23.7. Continue down. And 29.3 is a little less than 30.3. Okay, and so there is your area between the two there. Okay. The average miles per gallon of a new model of motorcycle is known to be normally distributed. Same words, but this time we want to suppose the area under the normal curve between those two numbers was 0.6419. We want two interpretations of that result. So again, remember, probability, proportion, area, all mean the same thing. So I wrote the two out underneath. The probability of the average miles per gallon between 23.7 and 29.3 is 0.6419, and the proportion of motorcycles that get between the 23.7 and 29.3 miles per gallon is 0.6419. Okay, these next questions are all coming directly off of Table 5. So you're just going to need to look these up on Table 5. They're all right here. So the area to the left of 1.5 is 0.9332. The area to the right, remember the table only tells you the area to the left, so we need to do 1 minus. So it's 1 minus 0.8907, which will give you an answer of 0.1093. Between those two numbers, again, you're going to look both of them up on Table 5. So I wrote what both of them were equivalent to. And then to find the actual answer here, the actual area, you have to subtract the two. Just remember, you're always subtracting the larger minus the smaller. You cannot have a negative area. Okay, and all I did on this slide, you can see over here with that blue asterisk, that's where I looked up that first one on the top there, just so you can see it inside the chart. And that's how I got that answer of 0.9332 for that first one. Okay, a new phone system was installed last year to help reduce the expense of personal phone calls that were being made by employees. Before the new system was installed, the amount being spent on personal calls follows a normal distribution with an average of $400 per month and a standard deviation of $50 per month. Find the probability that a randomly selected month had personal calls expense that falls below $250. Okay, so if you want below $250, we want less than or equal to $250. So again, we're going to need to go on to Table 5. To go on to Table 5, we're first going to need a z-score. So if we need a z-score, we're going to need that formula, x minus the mean divided by your standard deviation. All right, so your x here, x is going to be that 250. Your mean is that 400, and your standard deviation is 50. So when you divide here, you're going to end up with an answer of -3. So -3 now is what we're looking up on Table 5. And when you look that up on Table 5, you should get an answer of 0.0013. And that's your answer for that one. Okay. Next one, the amount of soda a dispensing machine pours into a 12-ounce can of soda follows a normal distribution with a mean of 12.36 ounces and a standard deviation of 0.24 ounces. Find the probability that the can contains between 12.31 and 12.37 ounces. So again, we're going to follow the same process that we just did on the last slide. We're going to find the z-scores for both 12.13 and 12.37. And once we find those z-scores and look them up on Table 5, we'll take those two values and end up subtracting them. So again, we're going to do the z-score, how about for 12.31 first? Again, I wrote the formula on the last slide, so I'm not going to write it again. So our x is 12.31, our mean is 12.36, again, that comes from right up here, and our standard deviation is 0.24. So when you divide there, you're going to get an answer of -0.21. So that's the z-score that we're going to have to look up on Table 5. And let's do the z-score for 12.36. So we'll have, 12.37, not 6. Erase. 12.37. So we'll have 12.37 minus 12.36. That's the mean. Divided by 0.24. When you divide there, you should get an answer of 0.04. So again, we're looking both of those up on Table 5. So when you look -0.21 up, that should give you an answer of 0.4168. And when you look up the 0.04, that one should give you an answer of 0.5165. So again, because we're going between those two, we need to subtract. Again, I cannot say it enough. It is always the larger number minus the smaller number. And when you subtract there, your final answer should be 0.0992. Okay, so about 10%. Next one, a firm believes that the internal rate of return for its proposed investment can be best described by a normal distribution with a mean of 43% and a standard deviation of 3%. What is the probability that the internal rate of return for the investment exceeds 50%? So again, this is going to be another straight table 5 question. So again, we're going to need our z-score. So this time it's going to be 50 minus 43 divided by 3. Okay, and when we do that as a decimal, that's going to come out to 2.33. So that's the z-score. And now we're going to look that z-score up on table 5. And again, we want the probability that it exceeds 50%, which is going to be greater than. Your table is giving you less than. So once we find the answer on table 5 for that z-score of 2.33, we need to remember to subtract it from 1. So we're going to do 1 minus 0.9901, which will give you an answer of 0.0099 as a final answer there. Again, I pre-slugged these. You want to find the z-score for which the area under the standard normal curve is, in this case to the left of 0.40. So again, this is when you're looking up in the guts of the chart. You want to get to as close as 0.4 as possible, and then you want to find the z-score that relates to that. For the next one, for the right, remember the table only tells you to the left. So the first thing I did was 1 minus that number, and then I'm looking up that 0.91 in the guts of the chart. And when you do that, those are the two z-scores that you're going to end up getting. And on the next slide, again, I did them both. So you can see inside the chart as close as I could get to both of those numbers, and then the z-scores that are associated with them. Okay, next one. The Board of Examiners that administered the real estate broker's examination in a certain state found that the mean score on the test was 442 and a standard deviation of 72. If the board wants to set the passing score so that only the best 80% of all applicants pass, what is the passing score to the nearest hundredth? Assume that the scores are normally distributed. Okay, so we're going to end up having to look for. Normally we find the z-score first and then look that up, but this time we're going backwards. So we're looking for that score that we need. So again, we're going to do, if we want a picture of what's going on, we'll say this area to the right is going to be our 0.80%, which means that your area to the left is going to be 0.2. Okay, and we want to find this score right there, which we're going to call x. Okay, so our area is 0.2. So that is what we are going to look up for our z-score. And when you look up that 0.2 for your z-score, you're going to get an answer of negative 0.84. So again, if I start with my z-score formula, again, I'll write it one more time just because this one's a little bit different. So it's the z-score is x minus mu divided by the standard deviation. Again, we're looking for x. Our mean is 442. Our standard deviation is 72, and we just found what that area is. It's negative 0.84. And now we'll just solve this. So the first thing I'll do is I'll multiply both sides by 72. So those will cancel, leaving me with x minus 442 is going to equal negative 60.48. And the opposite of subtracting 442 is to add 442. And when you do that, you are going to get an answer of 381.52. Again, it said to the nearest hundredth, so that's why I went out 2 spots after the decimal. Okay, the next question is asking us about looking at our Minitab plots to see whether our distribution is normal or not. So remember, to be normal, all of your dots need to lie in bounds. So the one on the left is not normal because all the points do not lie within the 2 bounds. And on the right, that is normal because all the points do lie within the 2 bounds. Remember, if a point lies on the boundary line, it's still considered in bounds. Okay. Couple more here. So decide whether you can use the normal distribution to approximate the binomial distribution, justify your answer. So if you want to know if you can use the normal distribution, this is when you want to know if n times p times 1 minus p is greater than or equal to 10. Okay, so your n and your p here, n is 70 and p is going to be 19%, which is 0.19. So what this is really asking you is 70 times 0.19 times 1 minus 0.19 greater than or equal to 10. And when you chuck that into the calculator, you're going to get 10.773. And we want to know if that's greater than or equal to 10, which it is. So yes, you can use the normal approximation. For the next one, a survey found that 10% of adults have dyslexia. You randomly select 90 adults and ask if he or she had dyslexia. Same formula. N times P times 1 minus P, and we want to know if that's greater than or equal to 10. Your probability here is 0.10. And your n is 90. So we want to know if 90 times 0.10 times 1 minus 0.10 is greater than or equal to 10. So if you chuck that left-hand side into the calculator, you're going to end up with an answer of 8.1. And 8.1 is not greater than or equal to 10. So this time around, you cannot use the normal approximation. Okay, the next ones are asking about adjusting for continuity. So if all conditions are met to approximate a binomial probability distribution with a standard normal distribution to compute the probability that x is less than or equal to 13 from the binomial distribution, you must compute what? So if you want less than or equal to 13, again, this is when you have to just include a little bit more. So let's say that was 13. Okay, and you wanted the probability, again, that it's less than, it's going to be on this side. So if you wanted to include more area, you're going to have to take this line and slide it a little bit to the right, which means we're adding 0.5 here. So we really want the probability that x is less than or equal to 13.5 in that case. Okay, same type of thing. We need to make our adjustment here, but this time we want for the probability that x is greater than or equal to 28. Again, it doesn't matter where you put it. It just helps you for a visual. Like let's say 28 is there. And this time we want greater than. And you want to include more area. You're going to have to slide that bar to the left a little bit, which means we're going to have to subtract 0.5 from that 28. So this is really asking us for the probability that x is greater than or equal to 27.5. If you want between two numbers, so between 8 and 15, this is when we're going to have to subtract 0.5 from our lowest one and add 0.5 from our top one. So this one is we want the probability that 7.5 is less than or equal to x, which is less than or equal to 15.5. Okay, and last question, the failure rate in a German class is 30%. In a class of 50 students, find the probability that fewer than 6 students will fail. Use the normal distribution to approximate the binomial distribution. Okay, so we want the probability that fewer than 6. So we want the probability that x is less than 6. So again, the first thing that we need to do is put that in terms of less than or equal to. So the first number that's less than or equal to 6 is going to be 5. So we're really looking for the probability that x is less than or equal to 5. And now that we have it with that equal sign, we need to make our adjustment. So again, we're going to need to move our bar a little bit to the right. So we're going to add 0.5 to that. So we are really, in the end, looking for the probability that x is less than or equal to 5.5. So now we're done with those two. So now, again, we need a z-score. So we're going to do x minus the mean divided by the standard deviation, which 5.5 is our x. Our mean is going to be, I have to find our mean. How about that? We have to find our mean by doing n times p. So our p here is 0.30 and N is 50. So our mean is going to be 50 times 0.30, which is 15. So 15 is my mean. Another aside, forgot to do the standard deviation as well. That's the square root of n times p times 1 minus p, or the square root of 50 times 0.3 times 1 minus 0.3. And when you do that, that should come out to 3.24. So put that into our z-score, and when you make a decimal out of this one, it's going to become negative 2.93. And again, now we're looking up that z-score on table 5, and when you look that z-score up on table 5, you should get an answer of 0.9983. And we wanted less than, so we don't need to do the complement. That is your final answer, and that is everything that you need to know for test 3.